Hey guys, it's Keith with Philosophy Acoustics, and I wanted to see if you guys are interested in a crossover upgrade for these Sony SS CS5s. These jobbies right here. I picked them up on Amazon when they were on sale for 88 bucks on Prime. I happen to have some membership points, so I only got them for 40 bucks shipped. Pretty smoking deal for me. I hooked them up and they sounded not bad. Um, I've certainly heard way worse. Like I picked up the Dayton's uh, the new bookshelf speakers with a 6-inch woofer, and they sounded absolute like just garbage. So, um, I wanted to show you what I have discovered about these and what I've designed and come up with, and I wanted to see if you guys were interested. First and foremost, I'll show you what I've done. Here is a crossover redesign. Um, the first thing that you need to know is that Sony claims these are a three-way speaker. Well, it has three drivers. Um, it's not three-way from what I could tell from the stock crossover. I didn't exactly map it out, so it might be a true three-way, but it certainly doesn't measure like it. From what I can tell, the tweeter and super tweeter, they're basically run in parallel, I think, and they're running on the same high pass filter. In my book, that just makes it a two-way with two tweeters. So I decided, hey, what if we can make this a true three-way speaker? And that's kind of what I've done here. Um, let's talk about it. Um, it is a kind of a strange crossover with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts, which makes me question if this is worth it or not, because 11 crossover parts, you're probably, if I had to guess, looking at between $60 and $100 to implement. Maybe less if you shop around, which is about the value of the speaker itself. But it might be worth it, and well, it'll be up to you to determine. You can see the values on the screen now, so if you wanted to go out and buy the parts and try this, awesome, go for it. Fully encourage you to do it. I hope you have a great time. So let's talk about what I'm doing here, and then we can go and look at the measurements I did en route to talk about some of the other driver responses and the challenges and whatever else. The woofer is basically a 5-inch woofer. It might be a 5 1/4. I don't know. Whatever, it's fine. In Rue, it starts to beam or become it had directivity issues around 3 kilohertz, which is cool. The mid or tweeter, whatever you want to call it, which is the next driver above the woofer, um, it starts to beam or become have directivity issues around 8 kilohertz, and the super tweeter a bit higher, past 10 kilohertz, which is probably fine for most people. And I thought, this is a nice recipe for a true three-way setup. And I think I discovered a potential crossover here. I have not built this yet. I have not tested it yet. I've just simply put it together after I did some measurements. So let's talk about those measurements, the way I did them. I measured with a calibrated microphone at the super tweeter level. I used acoustic time reference in RU, gated measurements up to almost 4 milliseconds. So we have some resolution down to about 250 hertz, which is great. Which is enough for me to design a crossover past a 1 kilohertz. So accuracy is going to be pretty good here. I did take off-axis measurement data for each of the drivers. We can go over those here in a few minutes. I'll touch on them briefly. But the important thing is that from my design perspective and my design goal of this crossover is directivity is important, but this is an $88 speaker. and it kind of is what it is. If I was super worried about my speaker having fantastic off-axis response, I would just design a speaker with constant directivity. But this is what it is, so we'll just live with it. Um, let's talk about what I did here. Woofer crossover point to the mid or tweeter, whatever you want to call it, is 2.6 kilohertz. Awesome. It is a second order slope with a 1 millihenry inductor and a 10 microfarad capacitor. Why such a gradual slope? It's only second order, and that's because let's jump into the measurement of the woofer itself. That's because the woofer has this gnarly peak at 1.1 kilohertz. That's kind of loud. 86 here at 300 compared to 91 at 1.1 kilohertz. So there's some weird inductance or maybe breakup mode going on with the woofer. That complicates the crossover. And every single time I try to go with a third order crossover, that peak is badly increased. It's accentuated, it's disgusting, it's very difficult to deal with. So it just kind of is what it is. I don't like. Let's just show you right now. Let's add another inductor to this woofer, and let's have a look. Yeah, it's kind of gross. You see what I'm talking about? It you're going to get some of this inductance peak anyways whenever you have these two big inductors, but we can lower it down like this. And it's kind of okay, but here's the problem. We have an inline inductor that's, 0.27 millihenries, and we're talking about a budget speaker here, and inductors are expensive and hard to get right now. And it's going to be, you're going to have a shit of a time finding a 0.3 or a 0.2 or 1.5 millihenry or inductor with low DCR. So you have your woofer output that's not going to cost you a fortune or even exists. I just don't think it's a good idea at all. So we're going to keep this at a second order slope because I think that's just what we need to do to be budget minded. This 1 millihenry inductor you can order from Parts Express as an iron core. It should cost you like $5. Do that. Go with iron core. It's fine. You're not going to be running enough power through this speaker to saturate that inductor, and if you did, the woofer will be toast. So I am not at all worried about distortion from inductance on the woofer, or excuse me, on the iron core inductor. So that should be a $5 part, maybe less if you shop around. You could buy, I think, a 2 millihenry inductor for like $7 and unwind it if you have problems finding 1 millihenries because they're pretty much out of stock everywhere. The capacitor can be electrolytic, 10 microfarads, fine, perfect. Let's have a look at the tweeter, or the 1-inch tweeter, or the mid, whatever you want to call it. You'll notice that it's a bit dampened right now. The reason why it's dampened is because we have kind of an impedance problem. It's a 4 ohm tweeter. I did my DATS measurements. It's kind of fine, but it being a 4 ohm tweeter or mid or whatever you want to call it, it limits our options on our crossover, especially when you start adding a bunch of parts. So as you can see here, these dips in the impedance graph at 2500 and 5.5 kilohertz are because of this tweeter's crossover. You'll notice that if I reduce the resistor in front of the crossover network, we start dipping into the low mid threes to get more linear response. I don't think it's worth it for me because I have PA amplifiers that don't give a shit about impedance, as low as 2 ohms. So would I run a 2 ohm resistor here? I would. I don't know about you guys, so I'm gonna say keep it at 3, and maybe it's okay that between 3 kilohertz and 5 kilohertz we have or 3 and 7 kilohertz we're a couple of dB down. You know, if you have DSP, probably don't if you're running these, but if you have DSP, that's probably easy to fix. Okay. The low pass is, or excuse me, the high pass on the the high pass on the tweeter is a third order with a 12 microfarad and a 7 microfarad cap and a 0.2 millihenry inductor. Um, it's fine. It's kind of necessary because the tweeter has a humped up response, you know, at 1800 kilohertz. It's kind of necessary. As you can see, there's already a lot of overlap between the woofer and the tweeter. This is not ideal. This is probably going to cause some directivity problems. I think it's okay. Um, the high, or the low pass or whatever. I've had 3 or 4 whiskeys. My terminology's messed up. But this part of the crossover here is just a second order crossover with a 0.4 millihenry inductor and a 5 microfarad capacitor. It's fine. Cool. The Super Tweeter has a third order high pass on it. 2 microfarad, 10 microfarad, and a 0.1 millihenry inductor. This can be a cheapo high DCR, like it just, oh, no, 0.1. Let's try this again. The resistance doesn't matter that much. I doubt you're going to get a full ohm, but if you keep it below half an ohm resistance, it doesn't care. So shopping for that part should be not bad. It should be a couple bucks for that inductor, and they're pretty available in Parts Express. The rest of the inductors, this one in particular is expecting 0.35 ohms. If you go higher, it's going to dampen the output. And as you can see, if we're at 2 ohms on that, which is insane, you're not going to find a 0.4 at 2 ohms. You're going to find a 0.4 at maybe 0.6. You can adjust the resistor in front to get your output back if you want. So you can play around with the resistor value or you can subtract the increased resistance on the series inductor for this mid by adjusting the value of your resistor in front of the entire network. It does kind of affect the low pass, but it's not that big of a deal. You know, it's already plus or minus 3 dB, which is pretty solid. So cool, awesome. Not a terribly complicated crossover. The problem is that it's just a lot of parts, and it's going to take some investment, and I haven't built it yet and put it in the box, and that's going to be a different kind of adventure. I will probably build this, and I could probably stuff it in the box. There's 1, 2, 3, there's 4 inductors, so I kind of have to do some finagling with making sure the inductors don't interfere with each other, but I think it's fine. Let's have a look at the actual measurements that I've done on this speaker, just so we can get an idea of what we're looking at. We'll have a look at, let's see, my measurements are out of order for some reason. What is this? Port? That's gross. Well, let's just so you know, the port is disgusting. It's got a big. Let's increase the gated window for this so we can see what the hell's going on. SPL phase limits 20 hertz. 80. All right. So now we get an idea of what the port response looks like. We'll zoom out a bit. There is definitely some leakage at 1.5 kilohertz. I'm going to stuff the hell out of this box, and that should cut down on that. Oh, my wife's calling me. busy. Uh, and you can kind of get an idea of the port tuning. It's about 60 hertz. It's not bad. This woofer is pretty good. Runs pretty well. I don't see my directivity measurements in my list that have the crossover built in. So I think I messed something up in my RU here. But let's just talk about the individual responses of the drivers. Let's have a look at the tweeter without a crossover at 0 degrees. Holy crap, can't see that, can we? Let's go 100 hertz, apply. Let's kind of move over. Not what I would call linear. Yeah, just kind of is what it is. We'll look at it at 15 degrees. Yeah, pretty gnarly. Past 10K, we're looking at significant drop in output. I don't really care too much about past 10K output. If it exists, it's fine. I can't really hear it anyways. 30 degrees. Reasonably good slope. These are gated measurements, by the way, to 3 milliseconds. So I took my this measurement is before the first reflection. So oh, by the way, these measurements are half a meter away from the speaker, so I can have more resolution. I tested a meter out before. The half meter measurements are basically the same. So we don't have any summation issues between the drivers at half a meter, and half a meter gives me more resolution. So that's what I did. Yeah, starts becoming, you get some directivity issues past 8 kilohertz or 9 kilohertz. Cool, whatever. If we look at the mid at half a meter without a crossover, which is the 1-inch tweeter, a bit choppy. This humped up response right here is annoying to deal with, which is why we had such a steep slope on the crossover. And let's have a look at it at 15 degrees. Yeah, not terrible. At 30 degrees, you can start seeing the drop off past 7 kilohertz. Not horrible. Let's have a look at the woofer at on axis 0 degrees. You see that humped response. Drops down and you get some of the cone breakup issues out here, and then it just disappears past 10 kilohertz. Kind of is what it is. Having that only second order crossover at around this area does allow for some of that to get in, but I think it's about 25 or 30 dB suppressed, which is 2%, I think, of the total output in that range. So 2% of it is your cone breakup. Call it 2% distortion. I don't know. Maybe that's not how that works, but I think it's going to be fine. The complications with adding in an extra inductor to increase the steepness of the slope, it was too much. And we're dealing with space issues in the box and component count, whatever. Woofer at 30 degrees, you can see it. You start getting some directivity issues happening around 2800 hertz. So that's the one I'm most interested in. So I'm going to go to my all SPL graph, which is insane mess, and clear the selections. And we'll look at 20 woofer. Let's have a look at woofer. Woofer. Disregard these 1 or 2 dB, these 1 dB differences. I'm not perfect with my mic distance when I rotate the speaker. So, sorry. But you can clearly see around 2800, maybe 3 kilohertz is where you start getting directivity issues on this woofer. I really like this. This gives us so much leeway with a crossover. And I kind of designed around it. So, I think it's going to be okay. Hopefully this incoherent rambling has been somewhat useful to you guys, or about 20 minutes on the recording. So back to the crossover. As you can see, at 2.8 kilohertz is when the crossover really starts to dip down, and the breakup mode is smooth a little bit. It's a little more spiky, which isn't that big of a deal. The smoothing is probably closer to what we're here anyways. We're looking at uh, more than 20 dB down, so not terrible. And then it drops like a rock, which is awesome. You can see where you start getting this hump the response right here with the tweeter, which is why we have the third order crossover on it to help just drive that into the ground. It is responsible for the extra output energy around 2 kilohertz. Since both drivers are practically omnidirectional, the summation should be fine for our directivity response. And then we have our super tweeter response crossover is around 6.5 kilohertz. Let's talk about distortion a little bit. So I want to jump back to Rue. Remember 6.5 kilohertz and 2.56 kilohertz because kind of important. So if we look at, I did some new measurements today just to confirm what I was doing. If we look at the tweeter, which is the super tweeter distortion, starts taking off right around 5 kilohertz, and we're talking 1% at 3K and 5% at 2K. So it really just doesn't like to play low. So if our crossover point is say 5, 6K, I think we're probably going to be okay on total distortions. Have a look. 6.5 kilohertz, 6.5 kilohertz, right here. So we're well above our distortion threshold. Noise floor here is kind of high, unfortunately. There's not much I can do about it. The air conditioner is running. It's freaking hot. So, great. Not bad. If we look at the 1-inch mid or tweeter, whatever you want to call it, it starts getting really unhappy around 1200 hertz, and it just goes up to 2% at 800 hertz. And this is about 90 dB measurement, by the way, guys. So it's playing modestly loud. I plug my ears when I run this because it's unpleasant to hear the sine sweeps. Not unpleasant, and there's a lot of distortion. Unpleasant because it's loud, and I'm a couple of meters from the speaker. So not bad, but keep in mind if we have a look at our crossover point, which is around 2 kilohertz, and it steeply drops after that, I think we could say we're doing okay on distortion for the tweeter. So the tweeter or the mid or whatever you want to call it is going to be pretty happy with this crossover. Let's have a look at the woofer. Definitely some box resonances going on. I'm going to stuff the crap out of this box, so hopefully that's going to get knocked down. But generally, the woofer is pretty happy below 1%. At relatively spirited level in a small room, so I don't expect this woofer to complain too much. There's a bit of increased distortion at 2.2 kilohertz, but that could just be some box resonance stuff going on. Like I said, I'm going to stuff the crap out of it. I think this is probably going to drop down, and then obviously it's super unhappy past 8K, and that's because the distortion relative to the output. I'll show you what I mean. Yeah, so output starts dropping, distortion compared to output is high. It's not playing that high anyway, so it doesn't matter. I don't know why I'm getting into that, but whatever. So cool. Yeah, I think the woofer is of decent enough quality to play the range that I expected to play in on this crossover, so I think it's going to be pretty happy. So that was probably way more details than you needed to know for the Sony SS CS5. Let me know if you guys have any questions. I will do my best to answer them. If you're really interested in this crossover, I will publish my final results with the crossover built, stuffed box, on and off axis measurements, except vertical. I don't give a shit about vertical. The distance between the woofer and the second driver is unfortunate. It's going to be shitty. I'm sorry. Vertical reflections in my room are not that big of a deal anyways. Horizontal directivity is probably the most important for imaging and soundstage on this thing, so I'm just not going to measure vertical. Sorry. Anyways, like I said, any questions, whatever, let me know, and I'll do my best to answer them. Uh, See you later.